So good evening all, and I hope you all are stay safe at your home. And before we start the lecture, I want to make sure that you all can see my screen as well as you all can hear me. So one student, please confirm the visibility of the screen as well as hearing of my voice.
Yes, sir. Clear. Screen and voice is clear, sir.
Okay, yeah, thank you very much. Thank you. And so we have a 66 numbers of participants now. And so hope the other members will join soon, and I will wait another 2 minutes till the other members to join the lecture. So please wait another 2 minutes. I'll start at 4:05. Okay, so let me start. So as one student clearly mentioned, and it is indeed a rainy day and very windy day, and situation in Belihulla also something very uncomfortable because of this heavy rain and then weather condition. So anyway, that since we are recording this particular lecture, and then later on I will upload this one to the LMS. Probably you all can follow this one. Even that one student is absent, then the particular student can follow this one. Right. So let me start. And so last week we have talked about projectile motion. So important thing is that the most important fact to remember is that the motion along perpendicular axis are independent and can be analyzed or can be considered separately. So this is the important thing if you just considering the projectile motion, as I mentioned several times, as I emphasized several times. The key to analyze two-dimensional projectile motion is to break it into two motions, one along horizontal axis, the other along vertical axis. So this is an important thing. The summary of the lesson is that මේ projectile motion එක මේ ළමෙක් මම අහගෙන අහනවා මොකද්ද projectile motion එක කියලා. අපි ඒකට සිංහලෙන් කියන්නේ ප්‍රක්ෂිප්ත කියලා. ඉතින් අපි මේ කතා කරන්නේ two dimensional ප්‍රක්ෂිප්ත ගැන. ද්විමාන තලයේ සිදුවෙන ප්‍රක්ෂිප්ත ගැන. එතෙන්දී මතක තියාගන්න ඕන වැදගත්ම දේ තමයි මේ motion එක අපිට කොටස් දෙකකට කඩා ගන්න පුළුවන්. So remember that the key to analyzing two-dimensional projectile motion is to break it into two motion. ඒක නිසා මේක දෙකකට කඩා ගන්න එක තමයි වැදගත් වෙන්නේ. One along the horizontal axis, the other along the vertical axis. The horizontal axis එකයි vertical axis එකයි තියෙන motion දෙකකට කඩා ගත්තාම මේක analyze කරන්න ලේසි නේද? එතකොට the important thing is in the case of horizontal axis, you have to remember that the horizontal velocity is always constant. there's no gravitational acceleration for the horizontal direction. Because of that, the horizontal velocity is always constant. ඉතින් ඔයාලට මතකයි මේක පොළවට සමාන්තර දිශාව දිගේ acceleration එකක් ත්වරණයක් පවතින්නේ නැහැ. ඒක නිසා ඒ දිශාව දිගේ මේ තියෙන velocity එක constant කියන අවස්ථාව තමයි ගන්නෙ. So in the case of vertical axis, it is the motion of freely falling object, and we have a gravitational acceleration to be considered in this particular motion. And then you can write your motion equation and finding the parameters which is in the case of this kind of motion. So once you combine this horizontal motion and vertical motion, and you can get a parabolic trajectory. As I explained previously, the objects are projectiles and the paths are trajectile. So this is the case that I have explained. And so it is basically the parabolic type of trajectory. In part එකට අපි කියන trajectory කියලා, මේ objects වලට අපි කියන projectile කියලා. එහෙම තමයි අපි ඉගෙන ගත්තේ. ඔයාලට මතක ඇති. මම හිතනවා ඔයගොල්ලෝ study කරලා නැති කියලා. So now you have enough time, and then please study at your home, and please prepare this particular note in perfect manner, and then study by yourself and ready for the next lecture. Then it's really easy, end of the day and end of the lecture, end of the course, that you don't need to do much more work since you are continuously working through the lecture. So this is really important, and please do understand that what you have to do is that we are working with the lecture. So it's very easy then. Then you can recall the things, and if there's any problem, you can do it. And it's something like a very easy recalling process, because just you are learned and then just you are recalled. So it's really easy. So this is what you have to do. And then I have given you several equations, and important thing is that the values of h is a height, maximum height, and also the distance a particular object is traveling. So it is h and r, and so h is a maximum height, and I derived the equation for simple h, and also the r, and which is depending on two parameters. One is angle, and the other one is initial velocity. ඔයාලට මතකයි මෙන්න මේ r කියන length එක depend වෙන්නේ parameters එකකට. ඇත්තටම ගත්තොත් the two factors would affect the projectile motion. So basically we have two factors affect to the projectile motion. One is angle, the other one is initial velocity. So we found that, so when the projectile is in the angle of 45 degree, we can get the maximum length. The උපරිම දිග හම්බෙන්නේ angle එක 45ක් වුණාම, and then you can change the initial velocity. So I have showed you several examples with the different velocities and also the different angles. So please do remember that mainly two factors affect projectile motion. One is angle, the other one is initial velocity. Hari, මේ ටික clear ඇති කියලා හිතෙනවා. මේ equations අපි ලියාගෙන තියෙනවා. Right. So let's move to one question, and then so if somebody is finished the question, and please text the answers, and if the answers are correct, and I will mark the name of the particular student, and then later on I will give you something, and it might be let's say a gift, and such a thing I will give to the student, and if the student is finishing in number 1, right? So answer should be correct, and so please type your answers here. And the question is very simple, and so an object is launched at a velocity of 30 ms minus 1 in a direction making of angle of 30 degree upward with the horizontal. So it's really important. It's upward with the horizontal. So it's mean that if you have a horizontal direction like this, and then upward with the horizontal and this direction, we have an angle of 30, and this is a projectile motion. So very simple, right? So this is what happening, and then v equal 30 ms minus 1. So I'll give you 10 minutes, and then please answer the following questions, and then please text to the text line, right? So this is what you have to do. And now it's 4:12, and I'll stop at 4:25. හරි පුංචි ගානක් තියෙන්නේ. ප්‍රොජෙක්ටයිල් කරන වෙලොසිටි එක 30යි, ඇන්ගල් එකත් 30යි. අපිට අහනවා මැක්සිමම් හයිට් එක, total flight time එක, horizontal range එක, magnitude of the velocity of the object just before it hits the ground. So you have something like you need sine 30 and cos 30, and you can find it here, right? So you can find these values here. Sine 30 is half, and cos 30 is that root 3 divided by 2. So please use these things, and then please solve the questions. I'll stop at 4:25. Okay, so then thank you very much, and it's really appreciate your commitment, and so a lot of students have already answered, and so I found that this student TEE 0211. So who is that student? This student TEE SCA 11 කවුද මේ student 211. So can you speak 2111? දෙසිය 11ට කතා කරන්න පුළුවන් මියුට් අන්මියුට් කරන්න මයික්‍රොෆෝන් එක. කවුද මේ 211? දෙසිය 11 අන්මියුට් කරන්න. Okay, so now it's enough, and please do not send the messages. And so I know I want to know that this student 211. So what is the name of this particular student? 211. So 211 student, he is the one who gave answers first, and which is correct answers. And so I surely give him this type of chocolate, right? So this is available here. And so once we meet, and I will give him this chocolate, right? Previously, that the time we can travel, and we travel a lot, and that particular time I brought a lot of items to give students, and but unfortunately so this time we cannot travel. ඉතින් ඒක නිසා අපිට දැන් රට රටවල් වලට යන්න විදියක් නැහැ. ඒක නිසා අපිට සිද්ධ වෙන්නේ මේ ලංකාවේ මොන හරි අරගෙන දෙන්න තමයි, right? Okay. Okay, so any question, Robert? So he raised a hand. So do you have any question? Anyway, that one student has asked me to do this question for you all, and I'm just trying to explain you that how to solve this question. And again, and I really appreciate your commitment because you have done a great job, and most of you have sent answers, and it's really good. And some students did this one within 4 to 5 minutes. It's really good, right? I really appreciate your commitment. Okay, then let's try to solve this question, because one student asked me to solve this one. And so let's do like this. And I'm not going to write all the equations, and I'll try to explain something. And so the situation is that we have a projectile, and you all know now the projectile. So it's kind of projectile. So this is the projectile, and with 30 ms minus 1, and also the angle is 30, right? This particular angle also 30, right? And so what we have to do is that we have to divide this motion into two, and this is vertical motion, and this is horizontal motion. So we need to find velocity for the horizontal motion, and then velocity for the vertical motion. So Vx we can write very simply, which is 30 cos 30. And then Vy is 30 sine 30. Right? This is very simple. And then if you solve more, that it is very easy that this is 15 into root 3. This is 15. Right? So now it's separate motion. So if somebody cannot understand, so what you have to do is that this is for the question number, I think it's B. And that question, so then you need to find the height of the projectile motion, right? So it's the height of the projectile motion. And so in the case of height of the projectile motion, which is given by the component y, and it reached its maximum value when the component y is equal to 0. So it's given by the component y, so this direction. And then maximum height is given when the velocities become 0. So it's starting with Vy and then moving, and then Vy becomes 0. In this particular level, you have a maximum height, right? So if students want to write, please write the height of the projectile motion is given by the component y, which is vertical motion, and it reaches its maximum value when the component vy is equal to 0. When this is equal to 0, this particular object reaches to the maximum position, maximum height, right? So please write that one if student cannot understand. Then you can write an equation here. And the equation is that V equal U plus AT. So you are starting with basically Vy component. Vy component is 15. And then you have acceleration. But the acceleration is in this direction. This is 10 ms minus 2. So acceleration in the other direction. So you put minus here, right? And then you can find this particular time, which is t, right? So in this equation, you can find the time, which is 1.5 seconds. And if you know the time, now you have to find the h. So you just put s equal ut half t squared to this particular direction. Now time is 1.5. So you know ut. This is 15. Right? This is minus 10. So once you substitute, now this is h because it's a height, maximum height. So you can get the answer as 11.25. Any questions so far? Yeah, it's okay. And so I can understand, and some student cannot connect, and because of this particular weather condition. And don't worry that this will be recorded, and then you can later see these particular videos, right? So please don't worry, student, and it's okay. And we can understand the situation, but I appreciate your commitment. And so I'll upload these videos, and later you can see this one, right? It's okay. And then which is basically flight time. Second one is flight time. Try to find the flight time. But now this flight time is twice like this, because now here we have a velocity zero position. So it means that the twice flight time of this one is a total flight time, which is 3 seconds. Otherwise, you have to write the equations, right? So equation is that now if you write equations for this motion, when the object reach to the maximum height and then reach to the ground. So in that case, you have a s equals 0. And then same time you have a velocity, which is 15 and t, and then a half 10 t squared. So if you solve this one, you can get t equal 3. So this is for the flight time for total flight, right? So flight time for the total flight, and or that it is twice of this particular situation. Whatever it is okay, right? So hope it is clear until now. And we found the maximum height, which is 11.25 meters. And same time, we calculated the time of flight, right? Then we need to find this horizontal range. In the case of horizontal side, you don't have any acceleration. A is equal 0. So this is very simple. So here it is R is equal to ut, right? So now you know the t, which is 3 seconds, and then you know the u, which is Vx, 15 into this root 3. And then you can get the answer. So that is around 77 something. So that one student, so you all know that the answer, right? So this is very simple. Now, in the case of finding velocity, now we have to finding the velocity here. So what we are doing is that we will find velocity this direction and then velocity to this direction. So this is not changing. This is Vx. It is not changing. It is 15 root 3. So we expect that this is changing. How it is changing? Starting with Vy and moving to upper level and then become 0 and then again increasing and reach to here. So if you don't think that you can find, you can write the equation Vy. Let's say this is a velocity, and then V sine theta is the initial velocity, and you know the flight time and also time. You know the flight time and also you know the acceleration. So you can write the equations here to here, right? So once you solve this one, the answer is minus 15. So minus 15. It means that all the directions are in this side and we are getting velocity to this side. So it is okay because velocity is for downstream, right? So this is 15 and this is 15 to 3. And if you get R, you can find which is equal to 30 ms minus 1. So similar situation, right? This situation is same as here, only the direction is different. This is projectile, this is where it is reached. And then answer for the D is 15, right? Sorry, 30. මම හිතනවා මේක තේරෙන්නේ නැති කියලා ළමයිට. තේරෙන්නේ නැති කියලා. දැන් මේකේ බලන්න මේ 30 ms minus 1 කියන එකෙන් පටන් ගත්තා. අපි මේ ගාන හදනකොට මුලින්ම කරන්න ඕන මෙන්න මේ x දිශාවටයි y දිශාවටයි තියෙන components දෙක හොයාගන්න එක. x දිශාවට තියෙන component එක 30 cos theta නේද? cos එතකොට 30යි මේ value එක අපිට හොයාගන්න පුළුවන්. y දිශාවට තියෙන component එක 30 sin 30යි අපිට මේ component එක හොයාගන්න පුළුවන්. ඊට පස්සේ අපි මොකද්ද කරේ මේකේ අපිට ඕන කරනවා මේ දුර හොයන්න තියෙන උස හොයන්න තියෙන්නේ මේ උස හොයන්න තියෙන්නේ මෙන්න මේ උස හොයන්න තියෙන්නේ උඩටම යන උස. එහෙම නැත්නම් අපි මෙන්න මෙහෙම ගත්තාම මෙන්න මේ උස. ඉතින් අපි මේක මේ y දිශාවට තියෙන එක වෙනම සලකන්නේ. වෙනම සැලකුවාම අපිට මේ පැත්තට g කියලා එකක් තියෙනවා. මෙහා උඩ යන්නේ vy කියලා එකකින්. අපිට මේ ටයිම් එක හොයාගන්න පුළුවන් නම් අපි හිතන්නේ මේක t equal 0යි. And this is t equal t. If you write the equation, you can find this particular value. So once you know the t, and then using s equal ut half at squared, you can find this particular s. This is h, right? So you can have h. Once you know this t, and the total time is t equal to t. Let's say this is total time, right? So once you know the total time, that you can find this particular length. This is r, right? So you can find r. So then what you have to do is that you have to find velocity to this particular position v, and then velocity here. This is remaining constant, and this is you can find. Then you can find the total velocity in this position. This is similar for this particular case. So now you can understand something is that this is something like a similar motion. So everywhere only the direction is changing. So here velocity is not changing, here velocity is decreasing. So same situation you have in this particular position. So only the direction is changing, right? Value is same. So this is what happening. ඔයාලට මේක දැක්කම තේරෙනවා මෙන්න මේ value එක තමයි වෙනස් වෙලා තියෙන්නේ. මේ sorry direction එක විතර වෙනස් වෙලා තියෙන්නේ. නැත්නම් value එක නම් එකමයි කියන එක පැහැදිලි. right? එතකොට ඒක තමයි තියෙන්නේ. ළමයි කියලා තියෙනවා මේ question එක අපහු පෙන්වන්න කියලා. ඒකයි මම මේක පෙන්නුවේ. දැන් මම හිතනවා මේක තේරුණා කියලා. Okay. So Gavin, do you have any question? Gavin Mihirika?
Sir, questions the travel time එක ගන්න සර් equation එකක් දුන්නේ මේ v0 sin theta කියලා මේකේ තියෙන සර්. display එක යන්නේ ඒක දාලා හදද්දී පොඩ්ඩක් මේ හදන විදිය පොඩ්ඩක් පෙන්නනවද?
නේද ඒක නිකන් ආදේශ කරන්න තියෙන්නේ. දැන් එතන
vy කියලා ගන්නේ sin theta නේද?
උට එන්න. එතන මේ මෙතන චූටි වැරද්දක් තියෙනවා. ඒක මම පස්සේ හදලා දාන්නම්. ඒ ඉක්වේෂන් එකට දානකොට පොඩ්ඩක් මෙතන ඇත්තටම s බෙදීම v0 cos θ කියන එක තමයි එන්න ඕන. s තමයි අපි මේ හොයාගන්නේ. නේද? s බෙදීම v0 cos θ කියන එක එන්න ඕන. එතනයි ඒකේ පොඩි වැරද්දක් වෙලා තියෙන්නේ. හරි මම මේක ආපහු චූට්ටක් බලලා දාන්න හොඳද?
හරි
හරි දැන් අපි කොහොමත් මේක දිහා බලාගෙන නෙමෙයි අපි ගණන් හදන්නේ. අපි සාමාන්‍යයෙන් අර මේ එන විදියට ලියලා තමයි හදන්නේ. හොඳද? දැන් අපි ඉක්වේෂන්ස් ටික දන්නවා. අපි මේ විදියට දාලා ගන්න. අර මේක අපි දැම්මේ අර මේ වගේ සම්බන්ධතා තියෙනවා කියලා පෙන්වන්නේ. ඒ කියන්නේ s කියන එක්කෙනා මේ වගේ එකක් එක ඩිපෙන්ඩ් වෙන්නේ. එතකොට අපිට පේනවා මේ t-යි velocity එකයි මත තමයි මේ හැමදේම වෙනස් වෙන්නේ කියලා. ඒක තමයි මෙතන පෙන්වන්න ඕනේ. right? හරි මම ඒක බලලා කියන්නම් ආපහු. චූටි පොඩි වැරද්දක් කොතන හරි වෙලා තියෙනවා ඒක ලියනකොට මේ ඒක මම බලන්නම්. right. හරි එහෙනම් thank you මේ question එක අහුවට හරිද? right. හරි දැන් මේක ක්ලියර් නේද මේ ගාන හදන හැටි ක්ලියර් නේද හැමෝටම? තව questions තියෙනවද? Is there any questions? So anyway, that 211 student, can you unmute your microphone and tell me your name? දෙසිය 11ට පුළුවන්ද එයාගේ නම කියන්න? Srimal.
Yes, sir.
Okay. Srimal, yeah. So I'll give you this gift, right?
Okay, sir.
Yeah. Okay. Thank you very much, Srimal. Right?
Okay, thank you, sir.
Okay. Okay, then let's move to today's lecture. And so it's very simple one. Today's lecture is all about circular motion. And අපි මේක වෘත්ත චලිත කියලා කියන්නේ සිංහලෙන් circular motion. And so you have to understand that it is defined as a motion of the particular along a complete circle or part of circle. ඒ කියන්නේ කවුරු හරි කෙනෙක් මේ රවුමට කැරගෙන එකක් හරි නැත්නම් පාර්ට් එකක් රවුම් එක කෑල්ල එක යනවා නම් වගේ ඒකකට අපි කියනවා circular motion එකක් කියලා. Right? So it is important that for a circular motion, it is not necessary that the body should complete all full circle. ඒක නිසා මේක අනිවාර්යෙන් මේ රවුමෙම යන්න ඕන කියන එකක් නැහැ. For an example, කාර් එකක් වංගුවක් ගන්නකොට ඒක circular motion එකක්. ඒකේ අදහස් කරන්නේ කාර් එක වටේම කැරගෙන්න ඕන කියලා. Right? ඒක නිසා even motion along an arc of a circle is a circular motion. පොඩි වෘත්ත කෑල්ලක යන එකකට අපි කියනවා ඒකත් circular motion එකක් තමයි. Right? Examples of circular motion including, for an example, an artificial satellite orbiting the Earth at constant height. Satellite එකක් මේ වෘත්ත චලිතයක යෙදෙන එක. නැත්නම් fan එක. ceiling fan එකේ blades කැරගෙන එක. නැත්නම් අපි හිතමු stone එකක් අපි ගලක් ගැට ගහලා කරකවනවා. So in that particular stone is moving in a circular path. And as I said, that a car turning through a curve in a racetrack, right? Or that electron moving perpendicular to the uniform magnetic field, right? So those all are some sort of circular motions, right? So as I said that, so it's not necessary that the body should complete a full circle, right? Please do remember that one. So we can say that a particle is said to execute circular motion when it's moved along the circumferences of a circular path, right? So this is what I have explained you, and you can write in your book circular motion, and then it is defined as the motion of a particle along complete circle or part of the circle. And then it's not necessary that body should complete full circle, and even motion along an arc of a circle is circular motion, right? Also we can write like a particle is said to execute circular motion motion, when it moves along the circumferences of a circular path. Right? This also can be considered as something like a definition for the circular motion. The මොකක් හරි particle එකක් circumference එකක් දිගේ පරිධිය දිගේ ගමන් කරනවා නම් පරිධිය පොඩි කෑල්ලක් වෙන්න පුළුවන්. ඒ පොඩි කෑල්ල දිගේ යන එක අපිට කියන්න පුළුවන් circular motion එකක් කියලා. ඒ චූටි කෑල්ල ගියා. කොහොම හරි වෙන්න ඕන අර පරිධිය දිගේ යනවා අපිට පේන්න ඕන. right? පොඩ්ඩක් හරි මේ දිගේ පරිධිය දිගේ යෑම අපිට පේන්න ඕන. එහෙනම් පේවොත් අපි මේකට කියනවා circular motion එකක් කියලා. So you can write many examples. So I have given you examples that electron moving in a magnetic field and car turning through a curvature in a racetrack. Stone is tied to a rope and it's being swing a circle. රවුමට කරකවනවා අපි ගලක් ගැට ගහලා ලණුවක. There are many, right? ඉතින් මේ වගේ ගොඩාක් circular motions අපිට හිතන්න පුළුවන්. Right? So then in the case of circular motion, now in the case of straight line motion or linear motion, important thing is this distance or displacement, which is x actually. So it's something like a measurable quantity. අපි කියනවානේ දුර හරි විස්ථාපනය හරි මේක තමයි important thing එක අපේ linear motion එකේ. So in the case of circular motion, the important thing is because we have to locate something. If the object is moving, we have to locate this particular object. Then translational motion එකෙත් එහෙමයි උනේ. කාර් එකක් යනවා පාරක් දිගේ. එනකොට so we have to locate that particular position with the respect of time. So we are basically measuring the displacement. So here also we have to locate where the particular object is available if the object is moving in a circle. Right? So important thing is this particular angle, which is so-called angular position. Right? So you have to understand the important thing in circular motion is angular position. Right? So please understand that the important thing is angular position, right? Which is theta. Right? So we can define the angular position theta by degree or radian. අපිට මේ angular position එකක් නැත්නම් මේ angle එකක් අපිට මනින්න පුළුවන් degree වලිනුයි අංශක වලිනුයි radian වලිනුයි. Right? Now for an example, you all are familiar. So what is the location of this particular star in degree and also the radian? So quickly, one student can give the answer. So obviously that theta of this particular position, now this is theta equals 0. This is the position where theta equals 0, and then we are measuring the angle. So can you define what is the angle using degrees and using radian? Right? So radian. This is defined in radian. So what is the angle of radian here? Which is equal to, so who can answer? Which is equal to
pi by 2.
pi by 2, which is equal to pi by 2. Right? So if a student cannot understand, what we have to do is that suppose we have a length of intercept s by theta. අපි හිතමු අපි ගාව තියෙනවා කියලා theta angle which is formed by length of intercept s. Right? ඒකට අපි කියනවා intercept එකක් කියලා. ඒ intercept එක හදන angle එක theta කියලා හිතන්න. So we can define the angle of radian as that s divided by r. R is the radius of the particular circle, right? Then if somebody cannot understand, please write that suppose we have a length of intercept s by theta angle of a radius r, then we can define radian as s divided by r. So in that case, this theta is radian. This is radian, right? So we can define the angle radiant or angle theta radiant is that s divided by r. So let's say that if we have a s, which is one circle, so if it is one circle, so this s is equal to 2 pi r. And then r is same. Then this angle theta radian, if it is one circle, theta is equal to 2 phi. So one circle, it is 2 phi. In the case of degree, it is 360. Right? So that is why that one student is clearly mentioned, if it is 90, in this case it is 90, it is phi divided by 2. So please write this part if student cannot understand what is this radian, right? So I'll write here for a student who cannot understand this part. So please draw this one. And then what we have to write as that suppose we have length of intercept s by, so I cannot write theta here, I just write here, right? Theta angle. So it's not theta, so please denote theta perfectly. Angle of a circle of radius r then we can define radian of the angle theta as s divided by r, right? Then you can write the other parts. If s is equal to phi r, one circle, angle is 360, then theta we can get as 2 phi. So this is a relationship. 2 phi equal 360. So you can define anything, right? So here, which is 90 degree or phi divided by 2. So please write these things in your notebook. Right? This is where that you can define this particular angle. Okay, so hope it is clear now. So as I said that here in circular motion, we define angular displacement, right? We define angular displacement, which is delta t, right? We define angular displacement. Every time we define the angular displacement. So angular displacement is defined as an angle through which an object moves in a circular path. So if the object is moving in a circular path, it is the angle in radian. It is important, this angle in radian, right? This angle in radian between the initial and final positions. Angle in radian, initial and final position. So then theta f minus theta I is the angular displacement, right? So please do understand that it's a radiant angle in between the initial and final position. So please write the radiant angle in between initial and final position, which is so-called angular displacement. So let me say one example, and let's say that you have a runner. A runner goes around a circular track. So runner goes around a circular track of diameter 8.5 meters. So diameter 8.5 meters, right? And then let's say that entire track of distance of 60 meters. This track is 60 meters, right? So what is the angular displacement? If you run such a things, it's mean very easily. Sorry, it's not entire. Let's say that 60 meters, right? 60 meters like this. So this one is very simply, you can say that 60 meters divided by 4.25 meters. Right, so only the particular person runs this particular 60 meters, right? So then you can find this angular displacement, which is 60 divided by 4.25, right? Right, so angular displacement, and this is angular displacement, and this is what I have already explained you. This is S equal R theta, or that theta is equal S divided by R, right? So it is very simple, and so you have already written these things, and it is a radiant measurement of the angle, and so I have already explained this one, and delta theta is the angle displacement, right? If you want to write, then please write this one. Okay, so I want to teach you one thing, and so let's say that you have a uniform circular motion. Uniform circular motion, it means that the velocity, uniform circular motion, now you have a uniform circular motion, right? It's mean that the value of the speed is same. The value of the speed is same. It means if it is 20 ms minus 1, the whole the way it's 20 ms minus 1. How about in the case of velocity? So do you think velocity is constant? Speed is constant. In the case of uniform circular motion, speed is constant. So how about in the case of velocity? Is it constant or is it change? So let me ask from one student. And how about Adhikari? Is it constant or change? Velocity. In the case of uniform circular motion, is velocity changing? So the question is velocity changing? So anybody can answer now. Is velocity changing? How about Kavisha Milani? Is velocity changing in the case of uniform circular motion? Uniform circular motion, velocity is not changing. According to the Gavin Mihiraka, no changing. No, velocity is not changing. So how about Husan and Lasindu and then Naveen Dilshara? In the case of uniform circular motion, is velocity changing? So we have a question, right? Is velocity changing? Mama hanawa uniform circular motion neke speed deke magnitude deke ekai, speed deke ekai. Ekama gaanata yanne වෙනස් වෙන්නේ නැහැ value එක. එහෙම වුණාම velocity මොකද වෙන්නේ? Is velocity changing? In the case of linear motion, if the speed is 20 and then velocity also 20. Yes, exactly. So Robert, you are really correct. And then thank you very much for your answer. Yes, direction is changing. Because of that, velocity is a vector. Even magnitude is same. However, the direction is changing. So it means that velocity is changing. මතක තියාගන්න. velocity කියන්නේ vector එකක්. ඉතින් මේ vector එකේ අපිට පේනවා direction එක හැමතිස්සෙම වෙනස් වෙනවා. නේද? අපි velocity එක ගැන කතා කරනකොට විශාලත්වයකයි දිශාවකයි දෙකක් ගැන කතා කරනවා. We are talking about magnitude as well as direction. So it means that direction is changing. The value itself is not changing. However, velocity is changing because of the changing of the direction, right? So please write that one. And then next slide, I have clearly mentioned this one. So UCM means that uniform circular motion. And in the case of uniform circular motion, speed is constant, but velocity is changing. So please write this one in your notebook. Okay, we have a question. And Bandara, so you have a question to ask? KD Bandara? Might be mistake. Okay, so then you have to write, in the case of uniform circular motion, speed is unchanged. Speed is unchanged. Speed is the magnitude of velocity, which can be defined considering that one circle. So you have to understand, if time taken to complete one circle, which is so-called period. අපි මේකට කියනවා මේ ආවර්ත කාලය කියලා. සිංහලෙන් කියන්නේ ආවර්ත කාලය කියලා. Time taken to complete one circle, which is period. And then the distance traveled, which is 2πr. Then the velocity can be defined as a 2πr divided by t, right? So this is time taken to complete one circle, which is period, right? So frequency, api sankhyaathe define karnawa 1ට t කියලා. It is the inverse proportional of period. And then you can write the equation, the velocity is equal to 2πrf. This is what happening, right? So it's mean that if you have a object which is moving with the velocity, any velocity, and then the radius is r, and if you know the frequency, you can find the velocity, which is 2πrf. So please write this one. This is valid only for uniform circular motion. ඒකාකාර වෘත්ත චරිත වලට විතරයි මේක valid වෙන්නේ. අපිට මේක මේ විදිහට ලියන්න පුළුවන්. So it's a uniform circular motion. We can define the velocity, but remember that velocity is always changing, because this particular direction you can see which is changing, right? So velocity is not a constant. Velocity is always changing. However, the magnitude of the velocity is constant, right? Because of that uniform circular motion, which can be defined like this, right? So please write these things in your note. The students, please remember that I will check your notebook once you are made, and then it's really important you to complete your notebook, right? So this is really important, because this particular fundamental of physics and physics for technology will be basic foundation of your science knowledge. So you have to gather this particular science knowledge, because you will be some sort of scientist in your future. And then so it's really important that you have to gain good science knowledge to make your professional career in success, right? And then we can define this one parameter, so-called angular velocity. And this is defined as omega. So we can say that in physics, angular velocity refers to how fast an object rotates, or we can say revolves in relative to another point. So which is defined that how fast the object rotates. So angular velocity is basically a parameter which defines that how fast an object rotates, or we can say that revolves to another point, or that we can say that to relative to point, relative to any point, right? This will give you an idea about how fast the object is moving between 2 points, right? So this is angular velocity. And so we define this particular one, v equal to 2πrf. And then we can derive an equation, and which is so called. One thing is that the omega is very clearly we can define. So please write this one. This particular omega we can define very easily. Omega is theta, or we can say delta theta divided by t, because it's defined in between 2 points. How fast the change of this angle? This is omega. How fast you can change the angle? So its mean angular velocity is that final angle minus initial angle divided by time. It's mean that change in angular position by time. Change in angular position by time. So which is change in angular position by time. Right? This is where you can define this one very easily. Change in angular position by time. So here you have a velocity factor here. So you can see that this velocity is always defined tangentially. මේක අපි ස්පර්ශයක් දිගේ දාන්නේ මේ velocity එක අපි ලකුණු කරනකොට හැමතිස්සෙම මතක තියාගන්න මේ ස්පර්ශයක් දිගේ ලකුණු කරන්නේ. ඒක නිසා අපි මේකට කියනවා tangential velocity කියලා. Tangential velocity. Right? අපි මේකට නමක් කියනවා tangential velocity. එළියම මේක tangential velocity. Tangential velocity. ස්පර්ශය දිගේ ඒක අපි define කරන්නේ. Right? Tangential velocity. So there's a relationship between this tangential velocity as well as angular velocity. So please remember that the tangential velocity Vt is equal to r omega. So please write this equation. Tangential velocity Vt is equal to r omega. Omega is the angular velocity. Omega is angular velocity. R is the radius of the circular path. So we can define this one. Tangential velocity equal to r omega. Right? So here this is tangential velocity. So you can see tangential velocity. This is tangential velocity. Right? So it is on the tangential direction. Right? So hope it is clear. So any questions? Any questions? So I'm going to stop this lesson at 5:30. So next day, in Friday, I'm going to do some questions using these particular things, right? And then we have to define the accelerations here. Now we have defined the velocity and omega, angular velocity, and tangential velocity. So same time we have to define accelerations. So acceleration is that change in the velocity by time, right? So here, please do understand that you have a two type of accelerations. One is that acceleration towards the center. This is so-called centripetal acceleration. Centripetal means that center seeking. Centripetal acceleration, which is towards center, right? So this is the acceleration we call AC, and it is centripetal acceleration. And then same time we have an acceleration which is AT, it is tangential acceleration. So tangential acceleration because of that VT, because you have a VT, tangential velocity. So change of tangential velocity, which is happening, and then you have a AT, because VT is always changing, right? Because direction is changing. Because of that reason, now you have a AT. And same time, you have another acceleration, which is towards the center, which is so-called centripetal acceleration, right? So please write these things in your notebook. Is centripetal acceleration. And then you had a tangential acceleration. So important thing is this centripetal acceleration. This particular acceleration in this side, center side, AC. And then please remember one equation for this AC is that V squared divided by R. Since V equal R omega, we can write R omega squared divided by R, then which is R omega squared. So AC is equal to R omega squared. So you have a certain equations now. This can be derived. මේක අපිට ඔප්පු කරන්න පුළුවන්. නමුත් අපි මේක ඔප්පු කරන්න යන්නේ නැහැ මේ වෙලාවේ. මේක අපිට ඕන නම් ඔප්පු කරන්න පුළුවන්. මම ඒක නිකම් මෙතන ලියලා තියෙනවා. කාට හරි කැමති නම් මේ වෙලාවේ මේක ලියා ගන්න පුළුවන්. නමුත් වැදගත් වෙන්නේ this particular equation, centripetal acceleration is equal R omega squared. Or omega squared R. Right? මේක මතක තියාගන්න. මේක තමයි ඔයාලා මතක තියාගන්න ඕන part එක. Centripetal acceleration equal to omega varga R. So now you have another acceleration, which is so-called tangential acceleration. And because of that tangential acceleration, we have one parameter so-called angular acceleration. Angular acceleration. So angular acceleration, we normally denote angular acceleration as alpha. Alpha is that tangential acceleration divided by R is the angular acceleration. So student, please remember that you have an angular velocity, which is omega, which is equal to Vt divided by R. This is tangential velocity, and then same time we have an angular acceleration, which is this is AT. AT, tangential acceleration divided by R. Right? අපි ලියා ගන්න omega කියලා කියන්නේ tangential velocity divided by R. Alpha කියලා කියන්නේ ඒ කියන්නේ angular acceleration එක. ඒ කියන්නේ tangential acceleration divided by R. Same time, we have a centripetal acceleration AC equal V squared divided by R or omega squared divided by R. right? So just want to wrap up today's lecture. I want to end today's lecture. So important thing is in the case of summary, of today's lecture, and so just summarize today's lecture. It's all about circular motion. So it's mean that we have a circle, and then we have an angular displacement, which is theta, and then if it is s, if the radius is r, you can write theta as s divided by r, and then you can define angular velocity, which is vt divided by r. Then you can same time define angular acceleration, which is at divided by r, and then same time you can define centripetal acceleration, which is v squared r, right? Or that omega squared r, right? So this is a summary of today's lecture, and hope it is understandable. මේක තමයි අද lecture එකේ summary එක. මේකේ අපි කියන්නේ අපි define කරොත් circular motion එක යන object එකක්. ඒ angular displacement එකක් හදනවා theta කියලා. ඒ යන දුර s නම් අපිට angular displacement එක ලියන්න පුළුවන් theta in radian equal s divided by r. Same time the particular motion is having angular velocity, which is omega, which is vt divided by r. Then vt is always changing, and because of that we have acceleration, which is at. So same time we can define angular acceleration alpha, and same time, as I said, that every object is having acceleration towards center. This is so-called centripetal acceleration, which is omega squared r. So these are the basic idea you can get from today's lecture, right? And then same time is all the equations we derived for the linear motion can be converted to the angular motion, where that the velocity and omega, and this is acceleration, here's the equations. So everything can be converted to the particular equations. So these things are also valid, right? So linear motion, we have this type of equation. Now in the case of angular motion, you have this type of particular equations, right? So you can see that the velocities change to the angular velocity, and same time acceleration is changed to the angular acceleration, right? Velocity කියන තැන් වලට angular velocity එක ඇවිල්ලා, acceleration කියන තැන් වලට angular accelerations ඇවිල්ලා, right? ඒක තමයි මේකේ තියෙන සම්බන්ධතාවය, right? මම හිතනවා lecture එක ඔයගොල්ලන්ට පැහැදිලි වෙන්න ඇති කියලා. Hope it is clear for all of you. And again, I really appreciate your commitment, even this bad weather condition. So I can see that more than 70 students are participating. So it's really wonderful, and it's motivate us to teach you. And so we really appreciate your commitment. And thank you very much for participating today's lecture. And so next time we will meet in next Friday, and which is 16th, and meet at 4 o'clock. So I will send you the link later, and then you all can join the lecture, right? So till then, have a nice time, and hope you all stay safe. And this is a critical condition in the country, and so hope that everyone will safe, and then living with your parents and having a wonderful time at your home. And stay blessed, and then hope everything going fine for you. Right. So till then, have a nice time for you all, and then please work. And then next day we will do one question. Right. Thank you very much for everything.
Yes.